So welcome everyone again. We'll get started here with the loads analysis, reporting improvements, and if you're not already familiar, we'll also talk about the integrating systems management project as far as that relates to some of the other work pertaining to the 2017 release of the virtual environment. So we're going to start working with the end result of Larry, I guess you could say. And that is the new system loads and sizing report formatting. This is a massive project. We did do a lot of work on working with various engineers about what the requirements were to be able to get to this point. So we're going to sort of, the slides are going to work sort of at the end and work backwards into and build out from there and talk about the other work under the hood that makes these reports and these new reporting pieces possible. So these reports are available in both IP and SI units and will give you or give engineers the ability to have more information available on the details of following the ASHRAE heat balance methodology for system sizing. In North America, and in particular for LEED, and those types of rating systems where ASHRAE 90.1 is used, the sizing requirements are set forth in both that standard being 90.1 as well as in other standards pertaining to system sizing like 183 and Chapter 19 of the ASHRAE Handbook of Fundamentals. When it comes to sizing plants and loops, both the chilled water and hot water loops as well as the heat transfer loops can all be sized as a part of the work for the Larry project. They were sized previously and have always been sized in the VE, but the details and the information that comes out of the reports has been significantly changed. And this also allows us to get into space load and ventilation requirements in accordance with ASHRAE 62.1 and Standard 170, which are the two ventilation standards which are most commonly referenced in both the building codes as well as in the LEED rating system. So this type of information is also often really useful not only to the design engineers, but it is also often really useful to those doing the review of the projects to ensure that each zone, and I say zone intentionally, is receiving the appropriate ventilation air as required by the standard that governs. And the system loads and sizing reports get into more detail with breakdowns. You can see individual gains and losses per envelope as well as for looking at heat gains that are internal or losses that may be internal. There are notes on these reports that tell you whether the systems are draw-through or blow-through, which changes the temperature leaving the supply fan, the temperature, and also conversely changes the load of the coil slightly or can, depending on the configuration of the air handling unit. The supply and return and exhaust rates are all listed. This is a concise format to give quick feedback on the sizing for those checks at the engineering checks, if you will, doing system sizing. So prior to generating those reports, and there are also zone load reports and room load reports which will show live out of the software as opposed to just on a PowerPoint slide. These sizing reports can be generated by different devices peaking. So the user can select which device they want to have peak prior to generating the report. In other sizing tools that I've used in the past, this is sort of a mystery. It's not clear which equipment is peaking depending on the report, and the user is limited in their options as to which devices they can choose to report their peak or the conditions resulting from the peak at the device. We can also do the 62.1 reports as we've done in the past. Conversely, to make this all possible, Model It and Apache HVAC and Apache all had to be enhanced, or they had to have new features built into them. So the room type has been replaced in Model It, building space, and there are new subtypes that are room, void, return air plenum, and supply air plenum. And they all have different templates and different functionality. related to them, and I'll talk more about that in a minute. The plenums can also be automatically generated from Modelit with the plenum and void creator and space splitter, which has been reworked in a more logical layout, making it easier to understand exactly how the tool is working and what numbers mean what in the interface. The tool will then automatically generate the appropriate return air plenums and or supply air plenums, as well as the appropriate number of stratified zones, I should say specified by the user. And this leads to the ability for Apache and for the VE to have proper HVAC zones. This also will allow the user to have new functionality for doing load calculations for system sizing, whereby the plenums can be forced to have an offset temperature. This will then change the conditions of the coil because there is a temperature differential that would not otherwise be captured at the moment of doing load calculations. The user can also specify a certain percentage of convective gain to the return air plenum, for example. Like for example, if you have ventilated lights, or if you have some sort of heat gain that is going to effectively go through the acoustical ceiling tile directly into the plenum, or more readily into the plenum, and be dealt with in the space load, and that changes, again, the conditions at the coil slightly as well. In support of this, there are two primary methods now for using HVAC in the VE. The default when you install the software is APSys. In order to engage the return air plenums and all of the new functionality in Modelit and Apache HVAC, you must use the APHVAC methodology. This enhances a lot of capabilities as far as doing detailed load calculations. Will allow you to generate the new loads report format and get into a lot more detail. For example, you can have a series of rooms that are all part of one HVAC zone, and only one of those rooms has a thermostat, and the remaining rooms would then get a percentage of airflow based on what the master room or the thermostat room specifies is available. This is a big change because you no longer have to connect rooms or connect spaces as you've had to do in previous versions of the VE. The plenum templates are unique. Return air plenums have unique capabilities. I've mentioned those already. And the void templates the void space type are useful for a whole host of things, including earth tubes or unconditioned areas or voids. All of the plenum types, as well as the void, are automatically excluded from floor area calculations, and I'll show you that when we get into the VE live. You'll see that all floor areas are set to 0 for all of those template types. And when you're using Apache HVAC in the ApacheHVAC mode or methodology, the objects are intelligently linked to Apache HVAC as well. In other words, when you assign a zone from Modelit to Apache HVAC, you no longer have to assign the plenums separately. The plenums are linked directly to the new intelligent objects in Apache HVAC. So it's less clicking and less opportunity for error. Zones and zone groups are accessed from the Modelit browser, and they're accessed in other browsers as well. And you can build up your zones and specify which zone is the master zone, or master room, excuse me, as a part of the zone through a drag and drop interface. And you also have some very handy tick boxes to disengage or engage only plenums, voids, or occupied spaces. You can convert rooms and groups to zones. You can right-click. A lot of the functionality that you would expect to be there when you right-click is there, and this is also going to continue to be updated or developed going forward in the software as well. Works very familiar. For those of you who are familiar with rooms and room groups, zones and zone groups work in a very familiar methodology or way. You build them up with the different names and the different air handlers or zone groups, and you drag and drop them in the interface to build them up as appropriate. You can visualize results or you can visualize the inputs, aka and model it by using either a room's view or a zone's view. There's a toggle for both of those so that you can understand or do your interrogation of results in a very detailed way or the appropriate way. There's also a zone data dialog box, very similar to the room data dialog box, which will allow you to change individual zones, and tabular editing is also supported for the zones as well as for the rooms. There is a consistency check automatically built in as well in ApacheHVAC methodology, where it will check to ensure that the zones are valid and that they are assigned correctly in Apache HVAC prior to being able to run load calculations. So this further reduces the opportunity for error on the front end, makes it more likely that the first results of the loads are going to be correct. You can work in either zone or room components within Apache HVAC. And you can convert back and forth within Apache HVAC. There are examples in cases where you may need rooms instead of zones, like for example, radiant systems may work better if you have a room component control as opposed to a zone component control. So there is the ability to flip back and forth between these component types within Apache HVAC. Apache HVAC also now supports the direct delivery of ventilation air. So you can have separate air paths to a particular zone group. This makes it possible to have more accurate modeling and sizing of dedicated outside air systems as an example. The zone airflow distribution worksheet is accessible through the ISM interface as well. This will allow you to also change the master room, and it will also allow you to distribute the airflow appropriately. So in liters per second or in CFM, the air can be distributed as a percentage or as a number, and you can override the auto-sized values to match what's on the design documents. So when you assign a zone, if you have a underfloor plenum or if you have a return air plenum, the plenums that are linked in Modelit, that linkage or that intelligence, if you will, carries over into the zone or into Apache HVAC. So by assigning a zone, any plenums associated to that zone are automatically assigned correctly in the multiplex. So again, just reducing the number of clicks and also reducing the opportunity for getting the plenums matched up incorrectly with the zone component. There's a new component duct leakage rate. So if you, in the US, we use SMACTA, which is a construction quality of duct construction, if you will. So if you've specified a certain SMACTA construction category, you can account for the quality level or SMACTA rating, if you will, within both the sizing and the simulations. If you're not familiar with Apache HVAC, Apache HVAC uses the profiles in AP Pro to work with the controllers to do very detailed control capabilities on detailed HVAC systems. We've renamed some of the profiles, or many of the profiles, so that they become more clearly named. This is work carried forward from the ISM work from last summer, where the ISM work got rid of the loads data spreadsheets that were in a separate spreadsheet software tool and have now been fully integrated into the system parameters interface in 2016, meaning that we could rename some of these profiles to make it easier to understand what they are. So that's sort of all of the, I guess, the user interface pieces of it. There's more in the user interface pieces related to the loads analysis and reporting improvements project. Another one of the big things is how room/zone sizing is done versus how system sizing or system load calculations are done, and to facilitate how different engineers prefer to do load calculations for different project types or for different requirements around the world. For example, in the U.S., we have some government agencies which mandate load calculations are done a certain way, and then they require that the room loads, zone loads, and system loads have no diversity at all. So we now have the ability to easily toggle between doing system and room loads, room and zone loads and system loads. We now have the ability to easily toggle whether to include diversity at each of those steps or not. And if we choose to include some diversity, or if we choose not to include some diversity, do we want to have the design day load calculations include a full 100% internal gain for a 24-hour period, or only during the period when the zone would be occupied, or when the system would see occupancy? So we have new dialog boxes in place for making that much more straightforward, as opposed to having to manually force the variables to 100% and manually take them back down to diversity, then continue on with the loads. And we also now have an option to include some internal gain on the heating load calculation side. The defaults, these things are not ticked, and the defaults are set up as per, I guess you could say, most commonly used or most commonly seen or requested requirements. But they are there intentionally to make it easy for the users to have more flexibility in how they choose to size their HVAC equipment, and indeed how they choose to size the room airflows. So stepping back, stepping away from the rest of this, from the project that was specifically related to loads analysis and reporting, we'll talk about some of the other features in Apache HVAC before we jump into a software demo of these capabilities, or these features specifically. There is a new performance curves library that includes 152 model-specific electric water-cooled chillers from various manufacturers and their curves. And those curves are able to be viewed in either 2 dimensions, 3 dimensions, and its functions of capacity, EIR, and COP. The Apache HVAC hot water loop has been dramatically enhanced and improved. And this is a summary of all of the enhancements, so I'm not going to read them all. I'll go through some of these other slides, and we'll talk in a little more detail. So firstly, there's the separation of the loop capacity versus the heating equipment capacity. You can size the loops, so you can size the equipment. Sequencing table now has more detail in it, so you can sequence and stage multiple heating equipment options in a more granular way, and there's some additional auto-sizing options in support of that. There is a primary flow control option, which has different options for the sequencing table, or variable flow per demand. You can now have dedicated pumps, so you can have 1 pump per boiler as opposed to 1 pump for the entire primary and secondary hot water distribution loops. There is more support for secondary secondary hot water loops in general. So you can do up to, I believe the limit is 99 secondary hot water loops with different temperatures, different resets, etc. Now, I mean, if you have 99 secondary loops, you need to probably seriously rethink your design, but there's 99 of them there, I believe. So you can get into the different temperatures for the loops, sizing them in different ways. You can have scheduled loads and modulated loads as individual loops. You can have your domestic hot water all be served from the same boiler plant, just on its own loop with its own reset, etc. And then you have different options for where you have the preheating, the devices for the preheating. So they can live on different parts of the return water loop. The scheduled load component can be placed as either a scheduled load or a modulated load. And this is just a difference of, you can put it in a different location parallel or after the coils. This is just a difference between the profile type. So a scheduled load, you would use an absolute profile, and a modulated load, you would use a modulating profile. And then lastly, the sensible thermal storage model has been upgraded or enhanced slightly so that it now supports chilled fluid. So it could be water, or it could be a mixture of glycol with water as well. So that's the overview of the features contained in Larry, as well as some of the other enhancements to Apache HVAC. So we'll do a quick live demo here of those features. I don't see anybody with any questions at the moment, so we'll just keep plugging away here. So into Apache HVAC, and as I mentioned, the system types are all available in here. So you get these little flags, and I know why I'm getting these flags. I haven't updated my model to reflect the new zones I've created. So it will flag you that you do have a problem with your zoning. If you wish to have a separate ventilation path, you can double click on the junction and select this so that it will be a separate path. If you want to work out your zone airflow distribution, a shortcut to that is to double click on the zone, and this will allow you then to change which room is the master, and also work through the airflows related to each room that is a part of that zone, or that may be a part of that zone. The duct leakage rate can be modeled by double-clicking on the duct thermal properties component. This will allow you to specify where the leakage is and specify exactly which return air plenum is seeing the leakage, so that will all be accounted for in the load calculations and energy simulation as appropriate. A couple of other notes, not related to Larry directly, but you have the ability now to meter everything individually, and there are also new fan categories that relate back to Vista Pro to make it easier to track individual fan consumption energy. So again, for the likes of reporting for lead, you may have some process fans, and separating those out, that becomes a lot easier in 2017. I wanted to go look at, I'm sure you're all familiar, I hope you're all familiar with the Integrated Systems Management interface, and that also has a shortcut to the zone the zone airflow distribution, and the zone ventilation and everything. This has supplanted the loads data spreadsheet that used to exist. This is also, as of 2016, full support for 62.1 Appendix A methodology, not just the simpler table 6.3 method. If we go look at the loads reports, and we want to do load calculations, you can you can do the loads through the 90.1 Navigator, the PRM Navigator. But you can also access the loads directly through Apache HVAC. So this is where you get into the options associated with, do you wish to apply diversity? Do you wish to saturate the gain profiles? So if I do not apply diversity and I want to saturate the gain profiles because I'm doing room and zone load calculations, the options I have here are no, which would just keep the profile associated to that space type as the default one is, which is most commonly an ASHRAE space type. If I say yes to this, yes will allow for the profile to go to 100% internal gain. So for example, if it's an occupancy profile, there would be 100% of the people in the room or in the space for the full design day period, so for a full 24-hour period. If I said only during system occupied hours, that would force the profile to be 100% only when the diversity profile was 20% or greater. So for example, in the case of an office, an open plan office profile, we don't get above 20% density on the profile until we get to 8 o'clock in the morning. So between starting at 8 o'clock in the morning and ending at 6 o'clock in the evening, the profile would be at 100%, but it would be 0% during the unoccupied hours. So you have different options, again, for how you want to do those load calculations. from talking about a project like a hospital that that does not ever really shut down, and I want to account for that in my room sizing, or perhaps that's a better fit for system sizing, I can also come over here and decide to include some of the internal gains. Don't saturate the profiles, apply those diversity factors so I get a little bit of internal gain during the overnight hours, but I can account for that during my system sizing calculations, or room load calculations in this case. And then moving on to the system load calculations, I have the same options, I just have different defaults selected. So these are going to be set up for the most common requirements, whereby when you go to size your coils in your plant, you want to account for the fact that you might have an office building with offices and conference rooms, but not everybody's going to be in the conference room at the same time everybody's in the office. Because presumably everybody's having a meeting in the conference room and is not somehow simultaneously occupying their desk. Of course, you may have the building type or a condition where the owner's requirements are, well, let's assume that the meeting occurs, but everybody who's in the conference room, except for maybe one person, is from an outside, or they're visiting the office. So now I have the office occupancy at 100%, but I have the conference room also simultaneously at 100%. So you have the option there to do whatever is most suitable for the building and for your client's requirements. And then once we get into sizing, you're wanting to generate the sizing calculations, or the results into the new reports format. We have the ability to select the results files in question, and then to select which devices are peaking on both the cooling and heating. And we also have the ability to either include or exclude any of the oversizing factors that may have been included for the auto-sizing runs. And once those have been done, the reports will then be generated using one of the new scripts, and the reports will then appear in the Content Manager. And the ability to review the sizing calculations is accessible from the Content Manager. So these can be emailed. These are a PDF. They can be exported to PDF, send directly via email. You can upload them to TAP, etc. But as you scroll through these reports, you will see that in this case, I have a note down here noting that I did include my oversizing factors when this report was generated. You can also see that they are a system load and airflow are the coincident peak for constituent zones as simulated. The zone loads for cooling and heating are each coincident peak values with respect to constituent rooms with oversizing factors applied. So there are helpful notes here on these new reports to make it clear as to what was included at each phase or step in the sizing process. You can also see what is carried over and not carried over. The notes do help with all of that, and we get into our system load report. So we're peaking at a given date and time, and what the conditions are at that peak, what the areas, external areas are served for this particular system. And as we move into the zone, we can see what the zone is comprised of, what the conditions are for sizing at the zone. So we were at a supply air design. We're trying to, we said do the calculations at 55. We actually need 56 degrees to meet this zone cooling requirement, or space set point requirement. And we can see what the temperatures are, the mixed air temperatures, etc. And as we progress beyond the zone, we can also then get into individual rooms and see what the individual areas and exposures are for the rooms, what the conditions are, gains and losses having to deal with actual total loads, any room cooling coils and room units that are in the rooms are served by, what the room is served by, and et cetera, et cetera. Makes it much simpler to troubleshoot load calculation results. Another note that isn't directly related to the Larry project, but is a change for 2017, is the calculation and application of air density changes due to elevation. So the default requirement, or the default number that is used in the setting is standard, which is sea level. The user then has the ability to calculate and enter in their own reference air density. And the user also has the ability to let the software derive it based on the user typing in the elevation, reference dry bulb, and reference relative humidity. And then the software will calculate what the reference air density is. And that carries through all of the load calculations, airflow sizing, energy simulation, and infiltration models in the VE. So it's a perhaps not an important change for many of the projects in Europe, but it is an important change for, and makes it a lot easier to get those numbers correct the first time through. So that's load reports. I'll just do the hot water, the new hot water loops functionality here real quick. And then if there are any questions, I'll happily address those. So you can access the new features in the hot water loop by going to the hot water loop in Apache HVAC and double-clicking anywhere on the loop. You can also now start to build and add scheduled loads or modulated loads if you have a primary-only configuration, as this setting is. The heating equipment set with the new expanded load ranges, as well as a sequencing table is built in here. You can use the loop for hot water. So you can choose to use this loop as your domestic hot water source. If you change this to primary secondary, that then allows you to build up multiple secondary loops, which you can then rename to make them more clear. And you have the ability then to enable a secondary loop reset. So each loop can have its own independent temperature control, its own reset, which you can specify from any of the profiles that you build up, and have different temperatures associated to all of these loops. And then if you do also need to use preheating devices, when you engage the preheating devices, they have different places on the return water loop where they can be placed. So again, just making it much more flexible to accurately size and model many of the hot water systems, or many of the more complex hot water systems system designs that we've been seeing, not just in North America, but elsewhere for that matter. I think I've covered pretty much everything, at least at a high level, for Larry. And the benefits here, again, are a streamlining of the interface for doing load calculations in accordance with ASHRAE requirements. It's also giving the user more options for how they wish to do sizing. So if I go take a look here, apologies for that, if I go take a look here at my model it real quick, I can see that there are these new filters, so I have these new object types, and just to give you a quick view of how that works. If I wanted to come in here and set my parameter depth, for example, and then generate plenums from that automatically, the UI will allow me to do that and automatically generate those plenums. So I can do my space splits and everything, but it will automatically generate the appropriate bits, and then as I assign my zones, those plenums retain their association to the room or the space that they were generated from. So they are much more intelligent when you're using the Apache HVAC methodology, which can be selected from the pull-down here for settings, depending on what's project type. Now, whatever you choose to set here will be remembered by the software going forward. Thank you all for your time. I hope that you'll be able to use some of the new features in the VE related to the enhancements for doing more detailed HVAC system sizing, making that process easier and more streamlined.